Hello. Good evening. Am I audible? Can someone please confirm?
Yes, sir, you are audible.
Thank you. Wait a minute. I'm setting this up. I'll see if we have my minutes. Okay, so the session is being streamed and it's also being recorded. So let's get started. Okay. So hope my screen is visible to everyone.
Yes, sir, you are clearly audible.
Okay. Okay. So welcome to the third live session, which is basically around week 4. And week 4 is where we move into actual data modeling. So till now, what we were doing was a bit of, let's say, basic statistics for the business world. Now we actually get into the domain of data modeling. So can someone, or model building. So can someone tell me what is the topic in week 3, week 4? In week 4, what do we look up or look at? What is the business problem we are looking at? Anyone?
So sorry, can you repeat the question, sir?
The question is, what is the business problem that is looked at in week 4 of the course?
Economical issues like elasticity of demand and the demand response curve,
Super.
and
So, yeah, wonderful. So, in week 4, we are basically looking at the demand response curve, right? So, what is the business problem? The business problem is I have demand, or I want to predict demand. How to predict demand given price? So that is the question that we are looking at. How do I predict the demand given price? And in this, we are specifically looking at a relationship when the relationship is linear, right? Because we'll be looking at two stuff here. The first one is when the relationship is linear, and the second, this would be in week 5, when the relationship is non-linear, right? So this is what we are trying to look at. The business problem of predicting demand using what parameter? The price as a parameter. When the relationship is linear will be covered in week 4. And when the relationship is non-linear is covered in week 5. So why is this important? This is important from the context of elasticity. What is elasticity? It is basically a measure of how demand fluctuates. Right? So that is going to be the broad domain in which we are going to look at. Super. Now, to do this, what do we want? We want to predict, right? So whenever there is a prediction involved, whenever you have a prediction involved, this prediction is going to be done using a model. And what is the most simplest model that you can look at? What is the most simplest model that you will come across?
Linear regression.
No, regression is not the simplest model. The simplest model that you will come across is actually in your school level.
Sir, probability.
Not probability. Probability is not a model.
Y equal to mx plus
Probability is
c.
computation.
Y equal to mx.
Yes. Your simplest model is your y is equal to mx plus c. What is this model? What is this model called?
Linear.
Okay, it's a linear what? Linear what? Y is equal to mx plus c means what?
Equation of a straight line.
It's a linear or it is a straight line. It's a straight line model. This model is known as a straight line model. Why? Because this is what you are predicting. You have your x-axis, you have your y-axis, right? And you have points that look like this, and you are building this model. Y is equal to mx plus c. This, we actually create something new, which is known as the regression model. Right? Now tell me, the straight line is taught to you in what subject? The straight line model is taught to you in which subject?
Sir, geometry, mathematics.
It is taught in maths. Right? Those are all topics in maths. So it's basically taught in the mathematics. Right? It's taught in the mathematics.
Right.
Where is regression? So where is regression taught to you in which subject?
Statistics.
It is taught to you in statistics. What is the difference between the two? So, alright, tell me this. I've written the straight line model for you. What is the regression model? Can someone tell me? What is the regression model?
We deal with the error.
We
deal with the error.
What do you mean by? Tell me the entire model now. Since you have got it, tell me the entire model.
So it is a model used to study the dependency of two variables.
Tell me the equation. Tell me the equation. Regression, even let's call it simple linear regression. So what is the simple linear regression's equation?
W transpose x plus c.
Y is equal to,
W transpose.
okay, Y transpose, you are telling in matrix form, it's okay.
bxy times x minus x naught. Y minus y naught equals
Y minus Y naught.
equals bxy.
B X Y
So xy is subscript actually.
B X Y, yeah, okay.
Times x minus x naught.
X minus X naught. What is X naught? What is X? What is B?
So x naught and y naught represents the mean value here. Means the mean of the two variables that we defined, x and y.
Uh,
And xy and beta, like the beta that you have written, it is the coefficient. Or you can more simple language, you can say the slope.
okay. This is one point. No. This is not it. No, not this. Tell me in this. What is in a very simple form? Yeah, someone was telling to me in matrix. I'm just, since this is a simple linear equation, we don't need matrix. You can just tell it like this now.
Beta 1x plus beta.
That is all. But this is not complete. What is missing? Someone was telling in the beginning.
There will be
Error,
one
sir?
more error.
There is a error term epsilon. So y hat is equal to beta naught plus beta 1 x hat plus epsilon. So between these two, between this black straight line equation and the regression equation, the only difference is the epsilon. Because you are replacing m with beta 1, c with beta naught. Apart from that, everything else is the same, right? The only additional term here is epsilon, which is 0 in the first case. Epsilon is 0 in the first case. And there is an epsilon here. So what is the difference between statistics and mathematics? Why is that epsilon coming? Why is that error coming?
Because there is a
Because
like here is a deviation from
there is no, the points are not on the straight line.
on
There
the
is some
straight line.
variation. So
Variation.
these guys are sitting somewhere like this. There is a variability in the data. There is uncertainty in the data. So they are sitting like this, and to this variable data, we are fitting now a line that is going to be passing, and each point on that line is going to be fluctuating from this guy, and that fluctuation is the error. So this line is the mean line, right? And that fluctuation is the error. So when someone was telling y minus y naught is equal to beta xy into x minus x naught, he was actually referring to the computation of this by assuming epsilon is equal to 0. If he had said plus epsilon, then it is basically this line that he is looking at, right? So he is putting x minus x0. This is basically x0. This line that goes to x0, y0 is the x0 line. That is the regression line. So anyway, that is very complicated way of looking at it. A more simple is this guy. So now this is your regression. Why does regression come into the business world? Because the data is highly variable. So now coming to our topic, since we are looking at demand response curves, what we do is we have the same problem. The only difference being x-axis is going to be price, y-axis is going to be demand, and we have different points or different combinations of this. We want to fit this line, right? So this is known as a linear demand response curve. That demand at a price P is nothing but, in your cases, it will be M into P plus C. This is how we will be modeling it. Sorry, my bad. Just give me 1 minute. I've made a small boo-boo here. This is your standard data, right? This is the curve. So it's going to be C minus M into P. This is the model that we do. Why? Because as price increases, the demand for the product is expected to drop. That is your general scenario. So this is known as a demand response curve, which has a linear relationship. Yes, no? All of you with me so far? Yeah?
Yes, sir.
Okay. So in this linear demand response curve, we have two terms, C and M. Okay? Now, when I set my price equal to 0, what will happen is to this equation? When P price is equal to 0, what will I get? I'll get D of P is equal to C. Okay. I will get, let's write it, D of P is equal to 0 is equal to C. What does this signify? What does the demand at price equal to 0 signify?
That there would be a certain demand as well.
That, okay, that will be a certain demand. What does it signify? This is my curve, price, demand, and this is what is happening. When P is equal to 0, this is D of P. So what does that signify?
When price is zero, the demand will be
Prices.
constant. So on further decreasing the price, the demand won't increase.
The demand, okay, you have to give negative price. We will not get into that. So what does this guy indicate?
Minimum, maximum demand.
Minimum.
Maximum demand.
That is the maximum demand. What does maximum demand mean from a business perspective? From a business perspective, what does that mean?
Sales, the revenue.
In the ration shop, they give ration for free. How many of you go to the ration shop and buy ration? Well, certain people will not go. So what does that indicate? From a business perspective, what does that indicate?
There is no revenue.
Huh? What is the
Minimum
word that
revenue.
I'm looking? It is okay. How do you say that? Let's say, uh, who's the top brand, top automobile manufacturer in India, or let's say top most selling selling vehicle brand in India? Hmm?
Maruti
Maruti. Super. How do you know it's Maruti? What measure are you looking at?
gives you the price and the
Huh?
purchasing power of the people.
Percentage?
The price as well as the purchasing ability of the people.
Purchasing ability, price, and all does not come here. Let's say it's the same price car. Yeah, Maruti. Let's say
Mileage,
this is
mileage,
not
mileage.
mileage. No. Then there are several parameters. Look, I'm not worried about the
Sales, sir.
parameters. So you are looking
After
at
the
something
service,
like the sales. You are looking at the sales parameter, right? The sales could be because of several reasons, but you are looking at the sales parameter. How do you say Maruti is Maruti? I know I don't want to use the term. So, uh, so when you look at look at all the manufacturers, and then you say Maruti is number one. How do you say Maruti is number one? What graph will you put? Let's go back to week 1. What graph will you put to show that Maruti is the number one?
So customer satisfaction.
No. I'm not looking at all of those stuff. All of those stuff goes into that number called sales. So I now know Maruti has sold, let's say, 100 cars. Mahindra has sold, let's say, 20 cars. Kia has sold, let's say, 2 cars. So how do you know that Maruti is the best brand?
Highest
What,
number.
what, yes, you'll just look at numbers. Huh?
Numbers.
What was the problem in looking at numbers, absolute numbers?
Sir, can you repeat your question?
What is the problem in just looking at these numbers 20, 25 and 2, or let's say 205 and 2? What is the problem in absolute numbers? Instead of absolute numbers, what will you use? If I don't want to use absolute numbers, what will I use? Let's say, huh? I'm trying to ask that word. I don't know whether my questions are wrong. Okay, let's come back. Let's leave all of that. When price is zero, the demand is so much. You are basically giving away free cars. And then also you are able to give out only 500 cars or 200 cars, whatever. What does that mean? What does that number indicate? It indicates the market size.
Market.
Beyond that, let's say you reduce price further, your demand will grow. But what is happening? You are basically telling, I am to take this product, take 20 rupees. Take this product, take 50 rupees. That is what you are trying to say, which is a very imaginary case, but no. So the worst thing that you can do is give the product for free. When you give the product for free, also the market will not take beyond a certain point. And this is a very, very common problem in the agricultural sector. We will basically say, I will give you my vegetables for free. Just take it out of my storeroom. But people will still not take it because of any reason, right? So that is known as the market size. That is why this is a very important concept, because it tells you the maximum size. Now, why is it important in this car context? Let's say there is 205.2. Then to arrive at market share, you cannot use 200 plus 5 plus 2. You must look at the market size and divide that by 200. Divide 200 by that, right? So, though you have 3 brands, 200, 5 and 2, market share of Maruti will not be 200 by 207. It will be 200 by demand at P is equal to 0. Get my point? Because other people who might have bought a car and have not yet bought a car are also potential customers for you whom you have not tapped into. Making sense? Yes, no?
Yeah.
Right? How many of you recently saw this TV series called Make in India, a Titan story? Anyone seen that series? If you have, again look at it. There will be a scene where basically they pitch for this Titan as a company, and they will say, how many watches will you sell? That guy would have actually done a market study, and he will come back with a concept like this only. He will say, I will sell 20,000 watches in a month or something of that sort. That number is basically arrived through this figure. Who is my potential markets? How many are there? Right? So that is going to be your market size. Super. Then this is when price is equal to 0. What is the second concept? The second concept is going to be when will demand be 0? So when will demand be 0? All you have to do is you want d of t is equal to 0, which means c minus m into p is equal to 0. Solve for this guy, which is nothing but p is equal to c by m, and you will get this price. What is this price? This is this guy. Why is it important? Why is that price important?
After this price, there is no relation.
It is basically the maximum price that you can set. This is the maximum price. So your operating range is between 0 to max price. That is your operating range. And in between that, you have a curve, which is modeled as a linear curve, which is going to be d of p is equal to d of 0 minus m into p. This is the model that you will build using data. Now, in an ideal world, you would have built it such that it's an exact fit. But here, in the real world, this will not be an exact fit. So what you will do, you will have d of p is equal to 0, 0 minus m into p plus some error, which is nothing but the predicted value at a price is nothing but the constant value plus the suggested price plus epsilon. Oh, sorry, I should not write it like this. My bad. I should have put the hat here. So your actual value is nothing but some predicted value plus epsilon. This is where we are fitting a demand response curve as a regression model. Yes, no? All of you with me? All of you with me?
Yes.
Okay. Now, okay. A small info. This is the error. This is also represented as epsilon, and there is something known as elasticity, which is also represented by epsilon. All right. So elasticity is nothing but the definition is rate of change of demand by, okay, let's not even go to rate. Let's look at percentage. Change of demand by percentage change in price. So this guy is nothing but the mod value d2 minus d1 by d1 by p2 minus p1 by p1. This is known as price elasticity. All right. This is known as the price elasticity, which is basically going to tell you how much has my demand changed, how much percentage has my demand changed for a change in percentage of price, right? Now this value, epsilon, can be of two types. Since we are looking at mod epsilon, the mod value, this guy can be greater than 1. Okay, let me put it. This guy can be equal to 1, or this guy can be less than 1. So there are three possibilities. When epsilon is less than 1, it is known as an inelastic demand. When epsilon is greater than 1, it is elastic demand. When epsilon is equal to 1, it is perfectly elastic demand. So these are the three options for you. Okay? Out of these three, from a business perspective, which one will you prefer? Which is the value for epsilon that you will prefer? Let's see if you are able to do a link. Epsilon is greater than 1, epsilon equal to 1, or epsilon less than 1. Which is your preference? As a business, let's say you are running a business, you are selling tea, for example. Which one will you prefer?
We will have to.
Huh?
We will have to come.
I'm not
So I
able to
want
hear you
that.
clearly. Will you prefer greater than 1, equal to 1, or less than 1? And why? Anyone? No? You would actually prefer inelastic demand. And the reason being, let's take a very simple Let's take a very simple example. If epsilon is less than 1, okay, let's say it's 0.5. What does this mean? d2 minus d1 by d1 by p2 minus p1 by p1 is going to be less than 0.5, which means what? Your change in the numerator is less than your percentage change in the denominator. So your demand is not fluctuating drastically with respect to price. So as a business, I have more control in changing the price. Even if I change the price, my demand will not drop significantly. That is what epsilon less than 1 means. When epsilon is greater than 1, even if I slightly change my price, my customers will leave me. The rate of change of demand, the numerator, is less than the rate of change of percentage change in the denominator. So my customers will immediately shift to a different brand if I change my price. That is the first case. In the number equal to 1 means perfect. If I increase it by 10%, my drop will be 10%. If I increase it by 15%, my drop will be 15%. Right? So that is the three cases. Usually, case 1, these two put together comes under elastic, and this is inelastic demand. And your business will always prefer inelastic demand. This is one way of computing. Another way of computing this elasticity, another formula is epsilon is equal to m into p by d0 minus m into p. Basically, d0 is nothing but d of p is equal to 0, which is nothing but d of 0. All mean the same thing, okay? So epsilon is equal to mp by d0 minus mp. First question, what is the difference between this formula and this formula? What is the primary difference? Okay, I believe everyone is in sleep mode or autopilot mode. I'll finish off fast then. Okay. The first formula is elasticity between 2 points. Whereas the second formula is elasticity at a price point. Right? You see there's only one P. That is the first thing that you have to remember. Another thing, whenever we give you a formula, you must know the root equation from which it is derived. So the root equation for this is demand at a price is equal to D0 minus M into P. This is the root equation from which this epsilon is derived. Therefore, if I change the root equation, if the root equation becomes demand at a price is equal to D0 plus M into P, the formula for epsilon will also change. It will change to minus M into P by D0 plus M into P. Alright, and of course, since you take mod of epsilon, the only the magnitude is taken. So epsilon is equal to mod of minus M into P by D0 plus M into P. Whereas in this case, your epsilon would be mod of M into P by D0 minus M into P. Okay. So the formula that is shared with you in the lecture is for a decreasing demand response curve. Whereas if you end up with an increasing demand response curve, the value for M should be taken as minus M and substituted in the formula. Alright. So please remember that. Okay. So this is yes.
So in short, there is no direct relation between these two formulas.
That is
There is no direct relation between these two formulas.
that is a direct relationship. No. What happens? In this case, M is equal to M. Whereas in this case, M is equal to minus M. Here M is equal to minus M. No. So the original formula, if you substitute, this was your original formula, right? So in the original formula, if you substitute that, you will get it. Or else, in a more simpler term, demand at price P is equal to D0 minus of minus M into P. So this goes into this.
But this is positive slope, right?
Is it?
This is positive slope, right? D0 plus M2.
This is positive slope. The green one is positive slope.
Okay. Got it.
This is positive slope. That is negative slope. So when there is a positive slope, the epsilon will actually be a different beast. Okay. Yeah. Okay. So this is with respect to demand response curve, modeling it as a simple linear regression, etc., etc. I have still not yet told you how you actually create a demand response curve given data. Let's say you have a data that looks like this. For different price points, you have different demands, right? Given this, how do you build a regression model? That I have not done. This I will not do today. Once MLR is done, I will have a separate session for regression modeling itself. At that time, I will talk to you about building simple linear regression and then extending that to multiple linear regression and its interpretations. Okay. So at that point in time, I will talk about complete regression concepts. What is your SSE, MSE, all of those stuff. How do you compute it? What are the formulas? What is p-value? What is hypothesis testing? With respect to regression model, all of that I will cover once your week 5 or week 6 contents comes out. Okay, week 5 basically non-linear regression, this thing non-linear demand response curve, and then regression modeling. At that point in time, I will cover complete building regression models. Okay. So with that, I will stop for today. It's a very, very active class today, so I will stop here. Any questions you can feel free to ask. We have around 6 people on the call. So if there are no questions, if you log off, I will also log off and close the session. Okay. Hello. Able to hear me?
So we'll be having the first four chapters.
Huh?
For quiz one, first four chapters.
Quiz one, what? First?
First four chapters, first four weeks, right?
First 4 weeks,
For
yeah.
quiz.
Week 1 to week 4. Yes. Till week
Okay.
4.
Okay, thanks.
So that's all. I will stop the recording, stop the sharing in case if someone wants to ask something off the record. Stop the recording.